In this video, we will discuss how to solve for delta H when you're given values for the bond energy or the bond enthalpy. This is a review from Unit 5, and what is really important to know is that this formula, and I'm going to highlight it in red, bonds broken minus bonds formed, that is not on the AP formula sheet. And so we want to make sure we know that. Bonds broken minus bonds formed. So how this works is you're typically given a table of bond energies or bond enthalpies, which what that means is this is the heat required to break these bonds. So for example, a carbon-hydrogen bond takes 413 kilojoules per mole. Okay, so what I want to do is I want to just do some practice problems to see how this works. If you're not given the Lewis structure, it's really important that you have the Lewis structure. That way you can see how many bonds you will be breaking. So for this first one, first of all, this is a combustion reaction, the combustion of methane. So right now I think I'm going to get a negative delta H because most combustion reactions are going to be exothermic, but I want to prove it with numbers. So I'm going to first draw some Lewis structures. We have one CH4, we have two O2s, and I'm not going to worry about lone pairs. We have CO2, and then we have two waters. Okay, so to break this, or to get delta H is going to be equal to all of the bonds broken. Some people like to remember, if they don't know how to do it, it's BB minus bonds formed, which is BF. Okay, so the bonds that I'm going to be breaking is, I'm going to be breaking 4 CH bonds. I'm going to be breaking 2 O double bonds. I'm going to subtract away 2 CO double bonds, and then I'm going to subtract away 4 OH bonds. And so to get these values, what I need to do is I need to look at this table up here. A CH bond is 413. An OO double bond is 495. I'm going to subtract away 2 times CO double, 799. These are in kilojoules per mole. I normally would put kilojoules per mole, but because of space, I'm just going to leave it out to make my work not too messy. Then I have 4 OH bonds, and that's going to be 463. Just like in previous notes, it's important that you add up each side. So this first side, this is 4 times 413 plus 2 times 495. This is going to be 2642. And then I need to add up this next side, 2 times 799 plus 4 times 463. I'm going to have subtract away 3450. So 2642 minus 3450. I end up with negative 808 kilojoules per mole, which is kind of what I expected because I knew it was going to be negative because it's an exothermic reaction. Now, what happens when you're given something like E? And in letter E, we have, this is called ethane. If you take organic chemistry, you'll learn that within the first week or so of organic chemistry. And so I have 2 of them though. I have O2. And what I'm going to do, just because I've got the technology here, is I'm going to copy this. I'm going to paste it. That way we can see. I'll draw 7 oxygens. I don't know that you'll have the space always to do this, but since I can make the space, I will do this. 4 COs. and then 6 waters. So this one is kind of as complicated as I think it gets, just because we got a lot of different molecules that we need to think of. And delta H is equal to bonds broken, which is BB, minus bonds formed, which is BF. So I am breaking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 CH bonds. So delta H equals 12 times CH. I'm going to break 2 CC bonds. I'm going to break 1, 2, 3, 4, 5, 6, 7 O double bonds. And then I'm going to subtract away 1, 2, 3, 4, 5, 6, 7, 8 C double O bonds. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 OH bonds. I've got to reference my table. I know some of them off the top of my head. That I've got 12 times 413 for the CH. A CC bond is 348, and I'm just referencing that table. An OO bond is 495 minus 8 times CO double, which is 799, plus 12 times OH, which is 463. And then again, like I've been saying, is we want to add up our two sides. And then, so 12 times 413 plus 2 times 348 plus 7 times 495. I get 9,117, and I'm going to subtract away 8 times 799 plus 12 times 463. And I get 11,948. And when I subtract the two, I end up getting negative 2,831 kilojoules per mole. This is a combustion reaction, so the fact that delta H is negative should make some sense.